This video, we're going to be tackling the merge sorted array LeetCode question. Probably one of the most popular LeetCode questions right now, and it's asked everywhere. So it's a great question. It's a great LeetCode problem to solve, but the description is totally confusing. But the title itself is very lending to what we're trying to do. We're trying to merge a sorted array, and they're going to give you two arrays here. Obviously, if we're merging, two arrays, if we're merging something, there has to be two of them, but there's a couple things we have to be concerned about. So we're going to take these two numbers right here. We have nums1, we have nums2, and we're going to place them within the very first array. So nums1 is going to take in nums2, and then we are going to sort them. But the thing is that we have to do all of the sorting within the very first array. So it's going to look something like this. So we're going to take these numbers from over here, and we're going to place them in here. So it'd look like 1, 2, 3, 5, 6. And that's what it'll look like when we get done. And notice something. We have these zeros right here, and LeetCode does this on purpose because this question would be infinitely harder if we didn't have those zeros. If we didn't have those zeros there, we would have to actually extend the array ourselves, and that would make this question hard. It would be infinitely harder. Also, LeetCode has been generous enough to even give us the length here. So we have a length here of 3, and that denotes how many numbers are in the actual array. So we have n numbers over here, so we have 3 numbers over here, and we have 3 numbers over here. And like I said, it makes our lives 100% easier. Next thing, how are we actually going to solve this? We're going to solve this with a variation of the 2-pointer. It's actually a 3-pointer. It's going to be a problem where we take the 2-pointer and we add an extra pointer. So we're going to have 3 pointers, but let's not get too bogged down. We'll talk about the pointers here in a second. Let's just talk about how would you solve this if you were just looking at it. A lot of these algorithms are solved almost as if we were solving them ourselves. If you were going to sort these numbers without using any methods, we can't use the sorting methods of your language. Whatever language that you're using, we can't use any sorting methods. How would you solve this without a sorting method and using 3-pointer? Well, first things first, you probably know that we're going to be putting the numbers right here, and you would just look over here and say, oh, that's a 3, this is a 6. How would we would just bring this over. We would just bring these 6 over. We would notice that the 6 is the biggest, and we would just bring it over like this. And now that we're done with the 6, we don't have to worry about the 6 anymore. We can move on to the 5 and so on and so on. We just compare these two numbers. We compare over here, we compare over there, and whichever number is the biggest, we would move it over. And that's exactly what we're going to do with the 3-pointer. So we're going to go ahead and make this a 0, bring back our 6 over here. And what we're going to do is we're going to assign 1 pointer right here, 1 pointer right here, and 1 pointer right here. And we're going to do that thing that we just did as if we were just solving it like we would without a computer, but we're going to pretty much computerize it. We're going to turn it into an algorithm. So 6 is bigger than 3, so we're going to go ahead, move over the 6, and we're done with this spot, so we can move this one over, and we can move this one over. Then we're going to do the exact same thing. 5 is bigger than 3, so we're going to move over the 5, just like that, and we're going to move our pointer over again, do the same exact thing. And we look over here, wait a second, 3 is bigger than 2, so we're going to move 3 over here, and then we're going to go ahead, move our pointer over, and 2 is bigger than 3, so we're going to move the 2 over right here, and congratulations, we've just sorted it. We've just solved this algorithm. Now we just need to go ahead, put it into code, so that's exactly what we're going to do. Let's go ahead, hop over into VS Code, and solve this thing. So we are inside of Visual Studio Code right now, and first thing that I'm going to do is I'm going to go ahead and start typing out the method. We're going to have a void return type because we're going to do all of the sorting within the first array. So we're not going to actually be returning an array, and we're going to be merging, and LeetCode calls this method merge. We're going to be taking in 4 parameters. This is going to be nums1, this is going to be m, this is going to be an array of nums2, and this is going to be int n. Now, key point. Pay attention to this m and this n right here. And this is actually supposed to be nums2. This is supposed to be nums2. It's very important to realize that this 3 right here is indicative of 3 values, not including the 0. It's very important to realize that. Also, right here, we have a value of 3, but this kind of just makes sense right here. There's 3 values in here, but just remember this m right here does not include the 0. It's very important to understand because we're about to be making the pointers. So the pointers are going to be pretty much given to us. We do have to do some finagling, but with the first pointer, we can just go ahead and get away with n-1, and we're minusing 1 because they're going to give you the numbers in a non-zero base index. They're going to be giving you the capacity. So P2, we're going to go ahead, say n-1, and they're not going to give you this value right here. So we have to have a third pointer, and we have to have this value at the end of the array. And the way that we do that is we basically add the m and the n. So we're going to say int I n plus n, and this is going to be n plus n minus 1. And that is going to pretty much create this value right here at the end for our third pointer. So moving along now, what we're going to do is we're going to go ahead and declare a while loop, and we're going to end this while loop once we get to the end of the second array, pointer 2. What exactly does that mean? So once we get to right here, this is when we're going to actually break out of the for loop and pretty much end our algorithm. And that is indicative of what we did on the whiteboard before. So once we get to the end of that second array, we're going to go ahead and break out of it. So next thing, we need to do a little check. We need to make sure that we are stopping once we get to the end of the first array, because obviously we don't want to iterate past that part. And we also don't the reason that we're going to do it this way is because if you don't do it like this, you're going to have to add a bunch of extra logic, and that extra logic is very difficult to write, and we'll have to add like 10 more lines of code. So this is the reason that we're going to go ahead add this p1 is greater than or equal to 0 right here. So this is the part of the code where we are going to execute, where we are going to do the switch if the value in the second array is greater than the value in the second, or the value in the first array is greater than the value in the second array. So if this value is greater than this value right here, this is when we're going to do the switch. So if this number were, just say hypothetically, if this were 8 or 7 right here, this is when we would actually move the value right here. So this may look a little bit strange to you. This may look a little bit confusing, but that's essentially what's going on. So we're going to say nums1, and obviously this is going to be p1. This couldn't be p2 right here because the second pointer is not going to be within the first array. So that's exactly why the code looks like that. So this is going to be if nums1 p2, and then we're going to go down into here, and then this is when we're going to actually do the switch, and we're also going to do the decrement. So we're going to say I minus minus, and what's going to happen is it's going to do the switch, then it's going to do the decrement. That's just syntactic sugar for what's going on. So nums1, and we'll say p1 minus minus, just like this. And here's where we can do the else right here. So we go down to the else, and this is going to be the exact opposite. This is when this number is bigger than this number right here. So if 0 was right here and 6 is bigger than 3, this is when we would move the 6 over. It's pretty much the exact opposite. So let's go ahead. We're going to go ahead, go back inside VS Code right here, and we're going to go ahead, finish this thing up. So nums1, minus 1, just like this. We're going to move over everything over into nums1, and this is nums2. So we're going to take everything out of nums2, or take that number, the bigger number, out of nums2, and we're going to decrement it just like this. And that's pretty much it. So let's go ahead. We're going to take all this code in here, and let's go ahead, copy it, bring it over into VS Code. So let's go ahead here, going to bring this over. Go ahead, put it in the terminal. I'm going to go ahead and bring this over 1. Also, bring this over and go ahead and run it. See what we get. Everything is accepted. We also have to make sure it's n plus n. It cannot be log, Gonna make sure that it's also the right time complexity. So the time complexity is n plus n. And let's also check out the memory as well too. Let's see what the memory is. And the memory is constant. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. And as always, thank you for watching.